Okay, so now to talk about CO2. If you notice, I didn't mention it when I was talking about atmospheric pressure, and that was because mostly it's negligible. It exerts something like 0.03 millimeters of mercury. So it doesn't have to go through all this process of dilution because for the most part, it's actually, we can say it's not even there. So just to go on to understanding how it works, let's understand the alveolar sac. And the alveolar sac is just a little pocket of tons of capillary beds, which the capillary beds of the lungs are called the bronchioli, right? So it's a little bag of capillaries, and that's a site of exchange for gases, right? So in the alveolar sac, only 15% is newly inspired air. So 15% of the actual the actual air in there is newly inspired air with new O2 and all of that. The rest is previously inspired air, so it has a bunch of CO2 collecting in there. And there's a very important reason for this, and it's to help maintain the body's pH. So we'll talk about what it does, and you've probably already talked about this a little bit, but that's why CO2, unlike oxygen, partial pressure of carbon dioxide is higher in the body than in the atmosphere. Okay? So understanding that, let's talk about systemic pressure, systemic circulation. So what's happening at the levels of the tissues is that the tissues are releasing their CO2 and giving it to the hemoglobin. It's attaching to the hemoglobin, and then it goes back to the vena cava into the pulmonary artery. Pulmonary artery is carrying the oxygenated blood. In this case, the oxygenated blood represents partial pressure of carbon dioxide at 46 millimeters of mercury. That is the partial pressure of deoxygenated blood. Just like with oxygen, right? The alveolar partial pressure of carbon dioxide is 40 millimeters of mercury. So just like oxygen, the area with higher pressure gradients moves to the area of lower pressure gradients. But unlike oxygen, where the gradient was opposite, right? So with oxygen, there was actually lower amounts here and then higher amounts in the alveoli. It's the opposite here, so that the carbon dioxide can diffuse down into the alveolar sac, and then the blood can get rid of